Hi, all. Welcome back to the lecture. In this lecture, we are diving into the exciting world of Robotic Operating System 2. It is better known as ROS2. The ROS2 is the next generation open source middleware for developing robotic systems. It's designed to make building advanced and robust robots easier than ever before. In this video, we'll cover the basics of ROS2, exploring its features, discuss the improvements over its ROS1. Coming to the introduction, ROS, in short, Robotic Operating System, is a framework for building robot applications. It provides tools and libraries that simplify common tasks like sensor data, communication, device control, and visualization. What is ROS2? ROS2 as a special toolbox for robots. ROS2 is like a toolbox filled with special tools for building and making robots. It's set of rules and programs that help developers to create and control the robots. What is this ROS2? ROS2 is the upgraded version. It's the 2.0 or upgraded version of the original robot operating system. Imagine ROS as the first version of the toolbox and ROS2 is the improved and newer version. So what made by Open Robotics? Open Robotics is like the company that designed and built this special toolbox. They created ROS2 to fix the problems or limitations that were in the first version, that is called ROS version 1. So why do we need ROS2? For fixing the problems from ROS1, that is the first point. That is the first thing we are switching to the ROS2. What are the problems we are faced in the ROS1? That problems that is fixing in ROS2. So coming to the point, fixing problems from ROS1. What is that? What are the problems we are faced? Like ROS1 had some issues or things that could be better. ROS2 was made to fix those problems and make it easier for people to build and control the robots. So what are the problems we have faced in ROS1? We will discuss in the coming slides. Next, coming to the next point, that is a learning from the past. Imagine if the first toolbox had some tools that were not perfect. ROS2 is like learning from that and making a new toolbox with a better tools. And coming the key features of ROS2, we'll discuss the key features in detail in the coming slides. But as of now, I'm briefing the key features of ROS2. The first key feature of this ROS2 is a more flexible. So what is a more flexible in case of ROS2? So ROS2 like a toolbox that can work with the different types of robots and programs. It's more flexible, meaning it can adapt to many different situations. And coming to the second feature, that is a better communication. So what is a better communication in case of ROS2? Imagine if robots needed to talk to each other, in case of that talking to each other, ROS2 helps them to do more efficiently. It's like improving the way the robots share the information and work together. That is about working together. And the third feature is works in real time. What is a works in real time? Means some robots need to make decisions super fast. For example, you can take ROS2 can handle this working in a real time. It's like the toolbox helping robots think and act quickly. And coming to the third feature, can speak different languages. Means different languages means not all robots use the same language, right? So ROS2 understand the different programming languages, making it easier for developers to use their favorite language like C, C++, Python, and OOPS. Coming to the security point of view, the next feature is security measures. Here, imagine if robots needed to keep secrets. So ROS2 has special features to make sure that the information they share is safe and secure, like keeping secrets within the toolbox. And the last feature we are discussed about in this introduction, that is teamwork and collaboration. This ROS2 is like a big community of people who like building and playing with robots. It's a toolbox that everyone can use and share, making it easier for people to work together on a cool robotic projects. In simple terms, ROS2 is an upgraded toolbox for building and control robots created by Open Robotics. It fixes problems from the first version and comes with a new features, making it more flexible, better at communication, and suitable for a wide range of robots. So it's like a cool kit that enthusiasts use to create amazing things. So coming to the features of key features of ROS2, here I listed the four key features, top four key features of ROS2. In that, the first one is performance and scalability. Second one is improved reliability and security. Third one is enhanced developer experience. Fourth one, additional features we are going to discuss. So under the key features of ROS2, the first one is performance and scalability. Under performance and scalability, we are going to discuss about TDS based communication, multi-threaded execution, multi-process support. And coming to the second key feature, that is improved reliability and security. Here we are discussed about quality of services and its policies and security mechanisms. Coming to the third key feature we are going to focus here is enhance the developer experience. Under that, language agnostic, modular design, and improved tooling. Now we are going to discuss about each feature in detail. First, we are going to discuss about performance scalability. Under the performance and scalability, we are going to focus on TDS based communication, multi-threaded execution, and multi-process support. So what is this performance and scalability in case of ROS2? Okay, so this ROS2, the newer version of robot operating system, as we discussed already, it uses something called data distribution services. In short, that is called DDS. This DDS to help different parts of robot to talk each other more efficiently. And for example, imagine a robot as a team of players in a game. They need to share information quickly and reliably to work well together. In such case, in the past, ROS1, they used a system like passing messages between the players. However, in ROS2, they use the method or technique or technology called DDS, which is like a super fast and reliable communication method. What is a reliable communication method? Exactly what it means efficient communication. What is the efficient communication? Instead of just passing messages as in ROS1, just passing the messages between these robots, and instead of just passing messages, DDS helps the players to share the information in a smarter and faster way. And second advantage is lower latency, or it is called as a technique or method, whatever it may be. Lower latency. Latency is like the delay between the sending and receiving the information. In such cases, DDS helps the reduce this latency or delay, making the communication almost instant. It's like a player getting updates very quickly, allowing them to react faster in the game. And third method is higher throughput. What is a higher throughput? Throughput is like a amount of information they can share. Like DDS allows them to share a lot more data without slowing down. It's like players being able to exchange lots of information without any hiccups. Reliability. In case of reliability, DDS makes sure that the information gets to the right player at the right time. It's like the having a super reliable postal services for their messages. So in simple terms, ROS2 with DDS is like upgrading the way the players in a robot team talk to each other. It's faster, more reliable, and allows them to share a lot more information, making the whole team work better together. And coming to the features of this uh, performance and scalability. So the first feature is middleware abstraction and DDS key features, benefits over ROS1 message queues, quality of service, security, interoperability. So these are under the DDS based communication. Okay, so what is a DDS based communication? As we discussed already. Okay, it utilizes the data distribution services for efficient and reliable data exchange, offering the significantly lower latency and higher throughput than ROS1 message queues. And coming to the middleware abstraction, that is under ROS2. So what it is exactly middleware abstraction? Middleware is like a translator. As for your understanding, I am assuming the middleware as a translator. So middleware is like a translator that helps the different parts of robot talk to each other. In ROS2 uses middleware, and one of its choices is called DDS, as we discussed. And why it matters? It makes communication between different robot parts more organized and efficient. So coming to DDS key features are publish subscribe method. What is this publish subscribe method? Uh, Imagine sending updates to your friends only when they are interested, like Instagram or Facebook or YouTube, like that. So imagine sending updates to your friends only when they are interested. DDS lets robot parts to do that by publishing, means sending information to the specific topics, and other parts can subscribe or listen to those topics if they are interested. Why it matters? It keeps communication focused on, avoids bombarding parts with unnecessary information. And next one is a data centric model. What is the data centric model is, instead of just passing messages, DDS is all about efficiently sharing the data between the robot parts. This is crucial for robots dealing with the lots of real-time information. So why it matters? It helps manage and exchange the large amount of data quickly and efficiently. And what about these benefits over ROS1 message queues? What are the benefits? Is a low latency. What is a low latency means? Latency is like a delay between sending and receiving the messages. DDS reduces this delay, helping robots react quickly to changing the situations. Why it matters? In fast-paced tasks like driving or medical procedures, quick reactions are crucial. And higher throughput. What is a higher throughput here is, throughput is like how much information can be sent at once. DDS in such cases, DDS allows robots to handle a lots of data without slowing down. Why it matters? For robots that need to process a lots of information, like detecting obstacles or making decisions. That is about throughput. Now quality of services, in short, that is called QoS. What it is? QoS is like setting the rules for communication. DDS lets developers control how reliable, durable, or timely the communication schedule should be. And why it matters? Why QoS matters? Different robot tasks have different needs, and QoS setting help to meet those specific requirements. And coming to the security, DDS comes with built-in security features. It ensures that the information shared among the robot parts is safe, like keeping secrets safe during the conversation. And why it matters? Especially important in tasks where security is a big concern, like in self-driving cars or medical robots. And coming to the interoperability, what is interoperability in DDS means? DDS is a standard that different robot systems can understand, making it easier for them to work together. Why this interoperability matters? Robots from different companies or teams can understand each other, prompting teamwork and compatibility. So that is a DDS based communication. Now, the second feature under this is multi-threaded execution. So what is a multi-threaded execution means? So whenever the threaded execution come into the picture, always we are going to talk about the nodes. This multi-threaded execution allows nodes to run process concurrently within a single node. Here mainly we are focusing on nodes in ROS2, multi-threaded execution, and what are the advantages of multi-threaded execution in ROS2? What is responsiveness, resource utilization, parallelism, and improved performance. Imagine a robot brain made up of different workers called nodes. Clear? Imagine a robot brain made up of different workers called nodes. Each worker means worker is considered as a node here. Okay. So each worker has specific job like seeing things in real time. That job is done by sensor nodes. So the jobs like seeing things, making decisions is handled by the control node, or moving parts. Moving parts is handled by the actuator node. So here we are considering three things. Each worker has sensor, control node, and actuator node. Sensor node seeing the things, control node making decisions, actuator node moving parts. Now, in the new version of the robot brain called ROS2, they added a feature called multi-threaded execution. This means that each worker, in our case that is node, right? Node can do more than one thing at a time. So each node can perform multiple things at a time. In the old way, like single threaded, a worker could only do one task in RAS1, like thinking or moving at a time. But now, with multi-threading, they can do multiple things simultaneously. It's like having more than one brain in the same head. And what are the cool features here is quick responses. What is a quick response? That is called responsiveness. Imagine a worker is busy doing something like looking at a sensor. In the old way, it would stop everything else, just focus on that. But now, with multi-threading, it can be keep doing other jobs while still paying attention to the sensor. This makes the robot react faster to what's happening around it. And coming to the resource utilization means using the resources better. Before, each worker would wait for its turn to use the brain's resources. Now, with multi-threading, they can all work together, not wasting any time for waiting. It's like having many hands working on different things at once. And parallelism, this parallelism we can call it as working together faster in our general language. Okay, so parallelism is one of the advantages of multi-threaded. What is a parallelism means? Multi-threading allows workers to team up and get the things done faster. It's like everyone in a group project doing their part at the same time instead of one after another. So, the robot with ROS2's multi-threaded brain can think and act more quickly, use its resources better, and get tasks done faster. It's like upgrading from having a single worker to a team of workers in the robot's brain. That is about multi-threaded execution. I hope all of you understand this. What is a multi-threaded execution? And the next one is multi-process support. What is a multi-process support here is this ROS2 is designed to support multi-process communication, enabling the creation of multiple nodes within a single process. So what is our features of this multi-process support is it is having the node based architecture, single process with multiple nodes, reduced overhead, simplified development, improved performance. Now uh, imagine a computer system like Windows or Mac operating system, but specifically designed to help robots to run and communicate. Now we are focusing on the node based architecture. What is a node based architecture is? I hope all of you understand what is a multi-process support means. To support multiple process communication, enabling creation of multiple nodes within a single process. Now we are going to discuss about the node based architecture. Means nodes are like individual programs for robots. Think of nodes as a small programs that control different parts of the robot. For example, one node might handle the movement, another could handle the sensors, and so on. So, nodes need to talk to each other. What is a nodes talk to each other is for a robot to work smoothly, these nodes must share the information. They do this by publishing means sending out, and subscribing means receiving to the topics, as we discussed the publish subscribe method, which are like communication channels. Traditionally, each nodes run separately. In the normal support or setup, each node runs as its own program or process. This is like having different apps running independently on your computer. And what this ROS2's multiple process support changes this is now ROS2 allows multiple nodes to run together within a single program or process. It's like having a several apps open within a single window on your computer. And what is a reduced overhead here? Why this matters? Reduced overhead. Running nodes together in a one process reduce the overhead, which is like the extra work your computer has to do to manage separate processes. It's like organizing the things in the room instead of spreading them out in a different rooms. And what is a simplified development? Why this matters is for developers the people making the robot software. Okay, having multiple nodes in one process makes it easier to write and fix the code. It's like having all your tools in one toolbox instead of scattered around the house. And improved performance. What is the improved performance here? In ROS2, sometimes having nodes in the same process makes the robot works faster. It's like having a team members working closely together, sharing information quickly instead of having them uh, instead of having them in different buildings. So in simple terms, ROS2's multiple process supports is like creating a more organized and efficient workspace for the different parts of robot, making it easier to build, debug, and run smoothly. That is about multi-process support. And coming to the next key feature of ROS2 is improved reliability and security. Under this, we are focusing on quality of service and security mechanisms. What is the quality of service here? Quality of service policies enable users to define and customize the characteristics of communication between the different components of robotics. I'll simplify this. ROS2 QoS policies are fine-grained control, data delivery, reliability, real-time scenarios, and customization. I'll simplify this quality of service. Imagine you have a bunch of robots working together and they need to talk each other really well and really fast. So ROS2 robotic operating system 2 has this cool feature called quality of service. What are the QoS policies here? QoS policies are like settings that let you control how the robots say the information. It's like having the remote control for how they talk. In that QoS policies, the first one is fine-grained control. What is a fine-grained control here is, this means you can be super specific about how the robots exchange the information. In such cases, you get to decide exactly how they should communicate based on what you need. That is about fine grained controller. And coming to the second policy is data delivery. Think of it like making sure that messages between the robots are reliable and show up the show up on time. It's crucial, especially when robots need to talk or work together without missing any important messages. And coming to the reliability, what is the reliability here is, this is about making sure messages between the robots don't get lost. You can set it up so that these robots are guaranteed to get the messages, which is super important in situations where missing a message could be a big problem. And coming to the real-time scenarios. What is the real-time scenarios is, sometimes robots need to respond quickly to the things happening around them. So ROS2 is designed to be really good at this. And QoS policies let you tweak how the robots communicate to make sure that they respond super fast. And coming to the customization, it's like having a personal chef for your robots. You can customize how they talk based on what they are doing, and you can adjust the things like how reliable the communication is, how much history they remember, and when messages need to be delivered. In a nutshell, ROS2 QoS policies give robot creators the power to control how their robots talk to each other. This is super important in situations where robots need to work together seamlessly and respond quickly in like in robotics and automation. That is about QoS. Now coming to the second one is security mechanisms. So, what is a security mechanism in case of robotics here is, in safety critical applications, secure communication between the different nodes in a robotic system is utmost important. So, ROS2 has incorporated various security mechanisms to address this concern, including authentication, authorization, and encryption. So, what is this exactly about secure mechanism is? Imagine if robots could talk to each other but could not be sure who they were talking to. That could be a problem, especially in situations where safety is a big concern, like hospitals or factories. What is the security mechanism in ROS2? The first one is authentication. Authentication means providing identity. Why it is important? Before robot starts chatting, they need to make sure that they are talking to the right friend or not some troublemakers. How it works exactly is robots use secret codes like secret handshake to prove they are who they say they are. This stops any sneaky robots from joining the conversation. And coming to the authorization, what is the authorization exactly is deciding what actions are allowed. What is the authorization? Deciding what actions are allowed. Why it is important? Authorization, why it is important in ROS2 in robotics. Once robots know who they are talking to, they need to make sure that those robots only do things they are allowed to do. How it works exactly? Robots get specific jobs or permissions like being a security guard or a chef. Rules are in place to make sure that they only do what they are supposed to and don't go off doing anything they are not allowed to do. That is about authorization. What is the encryption? Keeping conversations secret. Why it is important? Encryption means keeping conversations secret. Why encryption is important? Imagine if someone could listen in a robot conversation and understand everything. That would not be good, especially if robots are discussing important stuff. How it works, how encryption works. Robots talk in secret code language that only they can understand. Even if someone tries to eavesdrop, they won't be able to make sense of the conversation. So, in summary of the security mechanism, ROS2 security features make sure robots can trust each other, only do what they are supposed to do, and keep their conversations private. This is a super important in places where the safety is a big deal, making sure that everything runs smoothly and safely in the world of robots. And coming to the third key feature of this ROS2, this is the last key feature we are discussing in this video, that is about enhanced developer experience. Under the enhanced developer experience, we are going to focus on language agnostic, modular design, and improved tooling. What is these things exactly? We are going to discuss in the coming slides. What is a language agnostic? The statement language agnostic supports multiple programming languages like C++, Python, Java, etc. for flexible development. What this ROS2 supports multiple programming languages like C++, Python, Java, and how this ROS2 provides that flexible development feature here is language agnostic means ROS2 does not stick on just one programming language. This means developers can use different languages based on what they like or what the robot needs. It's like having options, and it supports multiple languages, multiple programming languages. Means ROS2 works with various programming languages. For instance, C++. This C++ is good for making parts of the robot working super fast. And coming to the Python, this is easy to understand and often used for trying out ideas quickly. And coming to the Java, works on different computer systems and is known for being adaptable. And what is a flexible development here? The ROS2 lets developers pick the best language for the job. If something needs to be quick, is use C++. If it's about trying to out new ideas fast, use Python. This flexibility makes it easier for different teams with a different language preferences to working together. Example, imagine building a robot. The part that recognizes things like objects or people might use C++ to be really quick, but the part that tells the robot what to do could be written in Python for speed and simplicity. This makes lets developers use the right language for each job, making things work better together. That is about language agnostic. Coming to the modular design. What is a modular design is it is achieved through the use of packages. Here we are discussed about packages, self-contained units of code, promoting code reuse and organization. So what is a modular design exactly is? Imagine a robot as a big puzzle. In modular design, we break the puzzle into smaller pieces that is called as modules. Here modules are called as smaller pieces. Each piece has specific job and can work on its own. This makes it easier to understand, build and take care of the robot. So Rust uses this idea to make building robots flexible and scalable. It lets developer to create and change the robots by putting together small self-contained parts that do specific things. And what is a packages here is think of a package as a small box in our toolbox. Each box holds the things like tools like code, notes means configuration files, and instructions like dependencies for a specific task. The packages make it easy to share and organize the tools. They help us keep our code neat and allow us to work on different robot projects without messing the things up. And coming to the self-contained units of code, each box or package has everything needed inside. It's like a kit with all the parts and instructions, so it works by itself. This makes it simple to share, reuse, and add the different robotic projects without causing the problems. And coming to the promoting code reuse and organization. What is the code reuse and organization is? Imagine if you had a set of tools that you could use for building different things, not just one specific item. Means you can use for multiple purposes. Packages in ROS2 are like reusable toolkits for building robot features. So you create a toolkit or called as a package for a job and others can use it in their projects. This keeps our code organized. It's like having a labeled boxes in our toolboxes, making it easy to find what we need and create well organized robots. That is about modular design. The next one is improved tooling. What is the improved tooling here is one of the key aspects of ROS2 is improved tooling, which includes new tools like Cocolon, like Colcon and RQT that enhances the development workflow. What is a Colcon and RQT? We'll discuss in detail about this Colcon and RQT in the coming videos. As of now, what is a Colcon here is it is a build. It is used for the build system improvement, modularity, and extensibility. And coming to the RQT, this is a GUI tool, means graphical user interface tool. It provides utilization and monitoring, extensibility, and integration with ROS2. About this Qualcomm and RQT, we'll discuss in detail in the next video. That is one of the feature of this ROS2. And these are the some references I used. So stay tuned for future lectures. I hope all of you understand this features of ROS2. and in-depth explorations and exciting projects within the realm of ROS2. So stay tuned for this future lectures. And if you have the specific topics you would like to us to cover or questions you would like to answer, let us know. We love hearing from our incredible community of this tech enthusiasts. Remember that the future is now, and with ROS2, the possibilities are boundless. Keep innovating, keep exploring, and until next time, happy coding. May your robots roam freely. This is Hemant signing off. Catch you in the next video. Thank you.